Okay, problem 14 of AIME 1 2019. It says find the least odd prime factor of 2019 to the 8 plus 1. Okay, for this problem, maybe you can, for example, check. You think, for example, one way is to check 3, 5, 2, 3, 5 all prime numbers to reach the first answer. But this solution is not a good solution for this problem. When we have a number theory problem, I said two tools that are so much important and you should pay attention to them are modula and divisibility. Sometimes you should use both of them. Okay, how can you understand which of them is useful? You can check both of them. And after solving some problem, you can understand which of them is better. For example, with respect to the problem. Okay. Here, suppose that P divides this. 2019 to the 8 plus 1, and P is a prime. If we want to write this divisibility with modula, it will be what? 2019 to the power of 8. Mod P is -1. Okay. And then we can raise both sides to the power of 2. It will be 2019 to the power of 16 is congruent to 1 mod P. Now here you can use order. And if you use order, you can reach good result. Okay, if you know order is what, pause the video and try first on your own. So let me tell you first definition is what? Order of, for example, A mod M. When it's D, it means what? D is positive integer and is the least positive integer such that A to the D mod M is 1. Okay, this is definition of order. And one important thing related to order is what? Is idea 3 is that if order of A mod M is D, and for example A mod N is 1 mod M, we know because by the definition of order, A to the D mod M is 1. Okay, and D is the greatest positive integer. So if for some other number, for example like N, A to the N is 1, then we can conclude D divides N. Okay, it is another important idea that here we want to use. So here, can you guess we should use order of what mod what? We want to use, let me write with green, let's consider order of 2019 mod P, suppose is D. Okay? By the definition, because D to the power of 16 is 1, we can conclude what by idea 3? What divides what? D divides 16. And now let's use another idea, Liddell-Fermat's theorem, so much famous. Liddell-Fermat's theorem. We can say if P is prime and GCD of A and P is 1, then A to the P minus 1 mod P is 1. Also someone, let me say another form of this is A to the P is A mod P and not necessarily GCD of A and P is 1. So, and both of them are equivalent. It is idea 4. So by this idea, we know that 2019 to the power of P minus 1 mod P is 1. Maybe you ask, how can we know that? Because one condition is GCD of A and P is 1. Why GCD of 2019 and P is 1? Because if it is not 1, it is P. And if it is multiple of P, if 2019 is multiple of P, then to the power of 2016 cannot be 1. Okay? Because this one is multiple of P, this one will be 0, then P will be multiple of difference. P multiple of P will be factor of... Let me explain this part if you've not understood. Here, I want to say GCD of A and P here, it will be what? 2019, and P is 1. If it is not 1, it is P, contradiction. Then this one will be multiple of P, so it will be 0, congruent to 1 mod P. So if you change it to divisibility, P divides 1 minus 0, 1. So P is a prime number multiple of 1, which is contradiction, okay? So 2019 and P is 1, And we can use this form of Lidl-Fermat's theorem. So 2019 to the power of p minus 1 is 1. Now again, we can use idea 3. And we can say what divides what? We can say, because of here, d divides p minus 1. Okay, now we know d divides 16, d divides p minus 1. Try the rest on your own. Pause the video. Okay, let's consider this condition. First one as first one, this one as second one, d divides 16, and this one as third. Okay, so if we write, first one will be what? 2019 to the 8th mod p is negative 1. It is first condition. Second condition, d divides 16. And third condition, d divides p minus 1. By applying first two conditions, we can say d should be 16. Why? Because, for example, from second condition, we know that d divides 16, d can be what numbers? Because d is positive. By the definition of order, it can be 1, 2, 4, 8, 16. Okay, I want to say these parts are not possible. Why? For example, if d is 1, it means what by the definition? 2019 to the power of 1 is 1 mod p. We know mod 8 is negative 1, so if we raise both sides to the power of 8, 2019 to the 8 is 1 mod p. And if you apply first condition, we know that 2019 to the power of 8 is negative 1 mod p. So by considering these two things, we can say 1 is congruent to negative 1 because left-hand sides are equal. 1 is congruent to negative 1 mod p. So we can say p divides the difference. P divides 1 minus minus 1. P divides 2. That's a contradiction. Why? Because p cannot be 2. Because the problem says. Well, find the least. We consider this as p. Least odd prime factor of this. Okay, so p is this one. So p cannot be 2 contradiction. Now, you can use same proof for 2. If it is 2, 2019 to the 2 is 1. You can raise both sides to the power of 4. Again, you can reach contradiction up to 8. So we can conclude d is what? D is 16. And from third one, we can say d or 16 divides p minus 1. Okay? So we can say p minus 1 is 16, for example, k. So p is 16, k plus 1. Now try to check prime numbers that mod 16 is 1. The first one that we should check if k is 1, p is 17. Okay, p is 17. Now try to check that does 17 satisfy this or not. Okay, pause the video and try first on your own. Okay, let's check 17. 2019 to the power of 8. We want to calculate this. 2019 to the power of 8 mod 17. Okay. Okay, 2019 to the power of 8 mod 17. We want to see it's 1 or negative 1 or other numbers. We want to see if it is negative 1. So, because we want to calculate mod 17, we should check remainder of 2019 when divided by 17. 2019 when divided by 17, it will be 1, 17, 31, 1, 17, 14, 149. Then we can check 7, 8, 9, 8. We can use 8. 8 times 7, 56. We have 5. 8 times 1 plus 5, 13. So it will be 4 plus 9, 13. Okay, so it will be 13. When you are working with mod 17, you can subtract by 17 or you can add 17. 13 minus 17 is negative 4, so it's better to work with negative 4. And because negative 4 to the power of 8, you can say 4 to the 8. Okay, and 4 to the 8, because negative to the 8 will be positive 1. 4 to the 8, you can say it's 16 to the 4, because 4 squared is 16. 4 squared to the 4. 16 mod 17 is what? Is negative 1. So negative 1 to the power of 4. Negative 1 to the power of 4 is 1. So mod 17 will be 1, not negative 1. So that's a contradiction. Let's check next prime number that satisfies 16k plus 1. Okay, if k is 2, 33 is not prime. If k is 3, 48 plus 1, 49 not prime. If k is 4, 64 plus 1, 65 not prime. If k is 5, 80 plus 1, 81 not prime. If k is 6, 96 plus 1, 97. Okay, now try to check 97, 2019 to the power of 8 mod 97 is negative 1 or not. Pause the video and try first on your own. Okay, let's check 97. 2019 to the power of 8 mod 97 is what? So first we should find 2019 mod 97 is what? 2019 mod 97. So you can say 2, 2 times 7, 14. We have 1, 2 times 9, 18 plus 1, 19. And it will be 7, 79. Okay, and 0. So the remainder is 79. So we can write 79 to the power of 8. But you can subtract 97 from 79. It will be what? 1 to 80. It will be negative 18. Negative 18 to the power of 8. Okay. Now in next step, we know negative to the power of 8 is positive, so 18 to the power of 8. 18 squared, you can write it as 18 squared to the power of 4. 18 squared is 324 to the power of 4. Now, if we calculate, if we find the remainder of 324 mod 97, you can write it as 3. 3 times 7, 21. We have 2. 3 times 9, 27 plus 2, 29. 4 minus 1, 3. 12 minus 9, 3. 2 minus 2, 0. So it will be 33 to the power of 4. All of these things, mod 97. Mod 97. Now we can calculate first 33 to the power of 2. We can write, let's write like this. 33 is 3 times 11. To the power of 4, we can write it to the power of 2 times to the power of 2. 3 squared is 9. 9 times 1, 2, 1 squared. So if we consider mod 97, 1, 2, 1 mod 97, you can subtract 97 with 324. So it will be 9 times 24 squared. So 9 times 24, 9 times 4, 36. We have 3. 9 times 2, 18 plus 3, 21. Mod 97. Okay, and if you calculate 216 mod 97, you can say what? This one, mod 97, it will be 2. 2 times 7, 14. We have 1. 2 times 9, 18 plus 1, 19. So 6 minus 4, 2. 11 minus 9, 2. So it will be 22 squared. 22 squared is 484. 484 mod 97 is what? Again, we can calculate the remainder. 484. Okay, 484 mod 97. We can write what? We can write 4. 4 times 7, 20. Or we can write also 5. 5 times... It will be 1 more than that. If you write 5, it will be 5 times 7, 35. You have 3. 5 times 9, 45 plus 3, this, okay? So it is not normal division, but if you subtract, it will be negative 1. So we can conclude that the remainder is 96, but you can say it is congruent to negative 1. And we wanted to find a prime, minimum prime, that it is congruent to the power of 8. 2019 to the power of 8 is congruent to negative 1 mod that prime, and this one is okay. So our answer will be 97. Okay, so the answer will be 97. Okay, we've considered how many ideas in this problem? 1, 2, 3, and also Little Fermat's theorem, 4. Okay, we have one homework related to AIME, and it says, for example, find something mod 1000, something similar to that, or last three digits. Okay, you can use similar things, and you can use also phi of n, general form of Liddell-Fermat's theorem. If you want to solve that problem, I should search the exact problem is what. Or want to learn more ideas in combinatorics, algebra, number theory, and geometry, feel free to send message to my WhatsApp number in the description.